Welcome once again. Let's solve the question on the board. The question says a 4 microfarad capacitor is connected in series with a 400 ohm resistor in a circuit. The connection is placed across a source EMF of root mean square value of 60 volts, alternating frequency 1500 over pi hertz. Calculate one impedance. Impedance is the overall opposition to the flow of current in an AC circuit and is denoted by the capital letter Z. But first of all, let's write out what is given in the question. We're given the value of the capacitor as 4 microfarad. Capacitor is measured in farad. Therefore, we convert from microfarad to farad by dividing it by 1 million. And that will give us 4.0 times 10 raised to power minus 6 farad. And again, in the question, we have resistance as 400 ohms. So we write here R equal to 400 ohms. And what again do we have here? We have root mean square voltage, that is VRMS, equal to 60 volts. And we have frequency as equal to 1500 over pi hertz. And again, we have pi as equal to 3.14. Then we try the formula for calculating impedance. This circuit consists of a capacitor and a resistor. Therefore, the formula to calculate impedance is the square root of R squared, that is resistor, plus capacitive reactant square. R is equal to 400, but we don't know the value for capacitive reactant. Capacitive reactant XC is equal to 1 over 2 pi FC. That will give you the value for capacitive reactant. So we can substitute. Since we have these values, we're going to have 1 over 2 times pi bracket 1500 over pi times 4 times 10 raised to power minus 6. So if we multiply this, we're going to have 83.3 ohms. So since we have the value for capacitive reactance, I will know the value for resistance. We can substitute this to this formula. So here we now give us 400 square plus 83.3 square, and this is equal to 166,943.88. And if we find the square root of this, it's going to give us 408.6 ohms. So the value of the impedance is equal to 408.6 ohms. Then on the second part, we're asked to find the potential difference. Because of space, we're going to clean this side. So let me write my answer here. I impedance is equal to 408.6 ohms. We said the potential difference across the circuit. Remember, potential difference V is equal to I XC, capacitive reactance multiplied by current. This is according to Ohm's law. We have the value of capacitive reactance as equal to 83.3 ohms, but we don't know the value for current. But current is equal to voltage root mean square over impedance, and voltage root mean square is equal to 60 divided by impedance, which is 408.6. If you divide this, it's going to here will be 0.1469. So this is the value for current, but we are looking for voltage. So we say therefore voltage will be equal to 0.1469 multiplied by 83.3, and this will give 12.24, and potential difference is measured in volts. So here becomes V. So the answer to the second part of the question is simply 12.24 volts. So these are the two answers to this question. Bye.